record one more time. So the screenshot I just put into Slack, so all of the following bullet points here become false when converted to a Boolean. So false is false, 0 is false, an empty string, NaN, our good old friend, not a number, null and undefined. So as far as evaluating conditionals or evaluating conditional statements and such, all of these will become false when converted to a Boolean. So something to keep in mind when you're creating your conditional statements. All other values become true when converted to a Boolean. Now, when we get to Ruby, just as a corollary, Ruby only has two things that are false, and that's false and nil. So it's a little bit easier in Ruby. Everything's true except for these two things. JavaScript has 6 things that will evaluate to false, false-y. So it's just something to keep in mind. One way to evaluate your values and variables and such is you can use the exclamation point or the bang. So when you add a bang in front of a value, the returned value will be the inverse of the value in a Boolean. So for example, the number 1 is going to evaluate to true, but how do we really confirm that? Because if you type in, the number 1, it's just going to evaluate like the number 1. But for example, if we wanted to see if that would evaluate as true or false, what you could do is a double, I'll put this into Slack, you could put a double bang before that number 1, and then JavaScript knows that you're asking to check the truthiness or falsiness of an expression. So if you ran bang bang 1, it would return true, right? And it's a little wonky because it's actually the opposite of the opposite. Each time you put a bang, it's going to return the opposite, right? So if we put 2 bangs, it's actually going to return the actual value, the truthiness of that value. So if you wanted to evaluate a string or a number or something, you could use that double bang to return a true or falsy value. So that's a really nice tip, something to keep in mind. Boolean and logical operators. Let's touch on this really quickly. These are really cool. So this is the double kind of and or the double pipes. So if you want to, these are considered binary operators because they need 2 things to evaluate to return a truthy or falsy condition. But we have the and the double pipes. I'm going to put into Slack a little chart of how these evaluate. Give me 1 second, let me pull that up. Actually, let me put this into Slack and just give you guys a little. So if I have something like this, what is this statement going to evaluate to and why? Does someone want to come on mic and explain that one? How will this be evaluated by JavaScript?
Isn't it like, and this is again stab in the dark, so isn't it false or falsy because when you have and, both statements need to be true?
Correct, absolutely right, yeah. So the and operator requires both statements to be true. So why is that important? Well, if you use the double ands, it's going to evaluate both statements on either side regardless, right? So you know that computationally it's going to have to evaluate 2 things because 2 things have to be true in order for the entire expression to be true. So yeah, it's absolutely right, Audrey. Very nice. Let me put something else in here. So if we use the double pipes, the OR operator, what will this evaluate to and why? Does someone else want to come on mic and explain this one? Dan, I'll call on Dan. So Dan, you want to walk us through this one, this OR operator? Yeah, so both of you guys are right. It will return true. Dan, you want to walk us through why that is?
Oh, okay. Yeah. False. Because both the left and right values are true, or is that?
Well, so the double pipes, that's the OR operator.
Oh, sorry, this is the one above it.
No, it's okay. Yeah, so I'll help you out a little bit there. Now Alejandra had the right idea as well. So as opposed to the AND operator, the OR operator, if either expression is true, then the entire thing is true. So it's actually kind of a short circuit. So when JavaScript sees that true or, meaning the double pipes, when it sees true or false, as soon as it sees the true Boolean, it just stops evaluating it. It's like, well, I know one of these is true. I don't even have to finish evaluating this statement. So the OR operator, if either statement is true, then the whole thing's true. The conditions that it's evaluating. With the AND operator, they both have to be true for the entire expression to be true. So that's how those work. So it's really important to keep in mind if you have something that's pretty could take up a lot of memory and bandwidth, maybe the OR operator is the way to go because it's kind of a short circuit type situation, right? If the first thing's true, and actually if you set up your statement where you know most of the time the first thing evaluated is going to be true anyway, if you happen to have some logic like that, then maybe the OR operator is a very inexpensive way to set up your code. So it could be really handy. The OR operator is also really handy to set up default values. Let me put that as a screenshot. That'll look a lot nicer. This is something that we're going to use a lot in our kind of full stack applications and stuff. Let me put this into Slack. So let's say that we want to set some sort of default value. This is really going to come into play when we get into full stack applications and we start using, when we incorporate authentication and authorization in our apps, which is pretty important, pretty heady stuff. We're going to be using this type of logic with things like a current user. Like, is someone logged in? Does someone have access to this part of the site or to the user profile or some sort of sensitive piece of information? We can also use the OR operator to set a default value. So let's say in this example, so we have a variable, we're declaring a variable name. And so if this variable other name is truthy, if it exists, then let's set the var name to that value. If other name doesn't exist or it doesn't have a value assigned to it, then let's make name default to the string mark. Let me share my screen real quick. We'll see an example of this. I think this is better just to see it. So I'm going to share my screen. Don't be alarmed. So let's set up a really quick example here. So let's say that I have a variable other name. And we'll set this to Schmitty, my favorite nickname. And we'll set up the expression first name equals other name or mark. And then let's return other name. Oh, sorry, let's return first name. Like so. So if we run this, right now we get, we console log Schmitty because Schmitty is truthy. Other name is truthy because it's actually something exists here. So when we try to assign first name, because other name exists since it's truthy, then we're going to assign first name to this other name. But what if other name doesn't exist, or what if we declare it but we haven't assigned it? Let's see if we get the behavior that we want here. So now if we run this, it's going to evaluate it. Other name is falsy, right? Other name actually doesn't even have anything assigned to it. So JavaScript is going to, in this OR statement, it's going to say, oh, well, this is falsy, so I'm going to default and just assign mark to this first name variable. So that's another way that we can use that OR operator. It's really a handy tool. So again, in this original implementation, we had Schmitty, since other name had a value assigned to it and is truthy, JavaScript doesn't even evaluate the rest of this statement. It sees that other name is true, and so it just assigns Schmitty to first name, and it just ignores the rest of it. So the or statement, the or conditional, is a really great way, you know, to save a little bit of memory, save a little bit of expense in the logic of your program. So it's just something to keep in mind again. Let's knock out the any questions about that one, about kind of the and the or operators. Cool. So let's hit this comparison operators and then the switch statement, and then we'll be at lab time. We're doing pretty good. So comparison operators. So how do we determine if two values, two variables, objects, two things are equal? So, or equal, greater than, or less than, etc. So we can use greater than, less than. In this example, you can see that it works with alphanumeric characters as well as numbers. So is capital A greater than A? That's false, because JavaScript just sees the value, not the capitalization in that case. Is the letter B greater than the letter A? Well, as far as evaluating alphanumerical characters, B comes later in the alphabet, so it's greater than A. And then it works with numerical characters as well. So you guys have probably seen this in JavaScript. There's the double equals and the triple equals, and sometimes they can get a little funky. Let's take a quick look at those. So equality in JavaScript can be a little complex sometimes. There's two ways that JavaScript verifies equality. So when we use the double equals, JavaScript does a lot of the type coercion in the background. So what that means is that if we use the double equals, JavaScript is going to coerce the types in the background, and it's just going to see if the two things are equal on a very superficial level. So if we look at these two examples here, if we see that dog equals dog, we see that that's true, no biggie. But where this really comes into play is, let's say that we have like the number 11 and the string 11. Now these are two different data types, right? We have a number and a string. But when we use the double equals, what JavaScript does is it ignores the data type and it just gets down to like the value of that data type. So whether it converts this 11 to a string so that we have two 11 strings, or whether it turns this 11 string into a number and tries to do the equality, either way, these are essentially the same thing. The number 11 and the string 11, it's not worried about data type. It's just trying to grab the value when it evaluates it. Now, if we really want to get specific and a little bit deeper, we can use the 3 equality operators. So this one is a little more tricky, but it's a little more precise. So to avoid that type coercion, if you're trying to evaluate not only the equality, but also the data type to make sure that that's equal, you'd want to use the triple equals equality operator. So to avoid that type coercion and measure equality more strictly, use the triple equals, because triple equals more truly measures actual equality. And we're going to use this far more often when checking whether things are in fact the same thing. So if we go back to this example of 11, the number, equals 11 the string. So if we do this again with the triple equals, now we get false, because not only is it evaluating is 11 the same thing as 11, but it's saying is the number 11 the same thing as the string 11, and it is not, so it returns false. So that's the principle behind that. The one thing, we'll talk more about this later, but the really interesting thing with this is how it evaluates objects. And we don't have to like worry about this too much right now, but when we use that triple equals with objects, objects are a special data type that we're going to get into a little bit later. And objects are a special data type because they're stored in a specific location in your computer's memory. So even though two objects may look the same, they're actually, each new instance of an object is actually stored in different memory locations. So they're actually individual instances of something. And a good explanation of this is this last example here. I'll put this into Slack. So these two arrays look like the same thing, right? They're both the data type of an array, and they both contain 1,7. They just contain two things, two numbers. So these would appear to be the same quality, the same thing, and the same data type. But when we run that, we actually get false. And it's a little wonky, a little confusing right now, but that's actually because arrays and objects, an array is a type of object. We'll talk about this later on. But like I said, they actually are stored a very specific way in memory. So we have to be a little careful when evaluating arrays and objects and things like that. And we'll talk about that later, but any kind of basic JavaScript data type, primitives, strings, numbers, booleans, and such, those will all play nicely with the double equals or the triple equals if you're trying to evaluate things. Any questions about double equals, triple equals? Most of the time, you're just going to want to default to using like the triple equals just to kind of, you know, better safe than sorry. So just something to keep in mind. Cool. The last thing I want to mention, and then we're going to hop into lab time. I know we're like a little bit over with lab, is just to briefly touch on the switch statement. So we have if-else statements and we have switch statements. If-else are obviously a little bit more common, but you do have switch statements at your disposal. So a switch statement can be used for multiple branches based on a number or a string. So usually if you have one thing that you're evaluating, and based on that one thing, you want to have several different branches or conditions, a switch statement is a really smart way to go. In this example that I pasted into Slack, we have a variable food that equals apple. And so based on this type of food, based on these different cases, I want to console log different things to the console. So I'm going to create a switch statement or switch case statement. Sometimes you'll hear it referred to as that. So in this example, I'm going to pass in the food as an argument into the statement. And then it's going to go through each case and do that comparison. So this first case, does food equal pear, the string pear? If it does, I'm going to console log I like pears. And then I'm going to do that break. So I have that break statement there. What does the break do? And we see that in a switch case. What does break do? See some folks typing. Yeah, it leaves the loop. So this isn't technically a loop. We'll talk about loops tomorrow, but yeah, that's the idea. So whenever we put that break, that keyword break, once the condition is met, then it's just going to exit the switch statement. Yeah, absolutely. Exits out of the statement. Yeah, thank you. So you guys can probably figure this one out. So we have two cases here. If it's a pear case, console log that. If it's an apple case, console log I like apples. And then the other cool thing about switch statements is we also have a default. So that's usually the last case that's listed. So if this evaluates and falls through all the cracks, we still want something to be returned. We want some sort of default result, something to happen. And so you can do that with the default case or default statement, and you usually want to put that at the bottom. So if nothing matches, then we're just going to console log no favorite. Here's one more quick example. You guys have probably seen this before. But let's say that we wanted to evaluate like the day of the week. So this has a couple of more, well, it should have 7 cases, right? So just as another example, and this actually uses a really great JavaScript method. So we have that capital D date. So date is another object in JavaScript that has a lot of great methods attached to it. One of those methods is getDay. So it returns the index of the day that we're currently on. So JavaScript keeps that time. You can try that out here in the REPL or in the console. So date is a function. It has a lot of different methods attached to it. So we could do date getDay. So what should be returned right here when I run date.getDay? What should we see?
Tuesday?
Huh?
Tuesday?
Not Tuesday.
Or today's date?
Well, try it out in REPL or in your console log in your browser. What's actually returned? Here, I'll run it in my REPL. We'll see it. So if I run date.getDay, oops, I must have misspelled it. Let me do that here in the console. Why are you breaking? Oh, I got to do new. That's my bad. Because it's a constructor. So let's do new. It's not a constructor. All right, let me check the docs on that. Here's the point. When you run the get day, it's actually going to return the index number of that day. So Sunday would return 0 because it's the first day of the week, and the index of 1 would be 0. Given that it's Tuesday, we should get 2 returns. So Sunday, Monday, Tuesday. I must have a typo in there. Let me check that out. Oh, I see what I did. I didn't call that first, so I needed to put my parens there. There we go. So if you call date.getDay, you'll see that you get the index of the day returned. And so in this switch statement, you can see that we're not checking Monday, Tuesday, Wednesday, the string. We're actually checking the index, the value that's returned. So if it's case 0, we know that the day is Sunday. Or case 1, we know it's Monday, et cetera, et cetera. So that's how that switch statement would work. But this is a pretty nice one because we have 7 different cases. So this wouldn't really be a good use case for an if-else statement, right? Because we're only evaluating the day of the week. And based on that one variable or one condition, we want these other things to happen. So there's a couple of bullet points here about like maybe when do you want to use an if-else versus a switch, or which one's faster, etc. For what we're doing, I wouldn't really worry about like the speed of it. It's really going to be pretty minimal. But when you're thinking about the logic of your program, use an if instead of a switch case statement if you want to test for the truthiness of an expression. So we're not really testing for the truthiness of the day of the week, right? We're really just trying to determine what day of the week it is. And based on what day of the week it is, we want like something to happen. So you want to use an if-else instead of a switch when you're actually testing for the truthiness of an expression. And if you only have a single affirmative test. So that's a little wonky, but just something to think about. But hopefully these 2 examples will help illuminate, if you have something like the day of the week that you're trying to evaluate, the switch case statement may be more appropriate. All right, so that's about it for control flow. We're going to talk more about loops tomorrow morning, so I'm going to punt on the while and do while loops. We'll cover those in the morning. But any questions about anything before we talk about lab time?
Yes.
Sure.
So
let's stop my share. Go ahead.
Let's say I would do date.getDay on Sunday. It would always give 0.
Well, so this is the current day of the week. So if it really was Sunday,
yeah,
it would return 0. Yeah.
Okay.
Check the documentation because JavaScript, that date object, it'll print out month, date, year. It'll print out like hours, minutes, seconds. There's different formatting that JavaScript will return. It's a really cool little module. It'll return a lot of cool stuff. Let me see here. Just going to see if I can show you really quickly, but yeah, we can take a look at that later. Any other questions before we hop into to lab time? Cool. So let me select out the README for your lab. Again, I'm going to put you guys back into your buddy BFF breakout room. So if we're going to click on that README, this is what I want you guys to work on during lab time. And so we'll walk through it just to make sure you guys understand what we're asking for. I would highly encourage you guys just to use Replit for this. It's going to be easy. I don't want you guys to worry right now so much about like the mechanics of doing stuff. I just want you guys to worry about like creating the logic and the flow of stuff. So don't worry about using Node in a separate script right now. But go ahead and click on that README and let's walk through this. So this is called Choose Your Own Adventure. I'm just reading from the README if you want to open it up there locally. So using what you know about data types, variables, etc., I want you guys to create a text-based game that allows the user to arrive at different destinations based on the inputs that they type. So there's some rules to this game. I'll put these into Slack. So this is what I want you to think about as you're planning out your logic. These are kind of your parameters, your rules. So the rules are any path that the user goes down in your program must ask them at least 3 questions. We'll take a look at an example here shortly. There must be a minimum of 7 total destinations that the user could arrive at based on their responses. So 7 different, endpoints. At least one of the questions asked, there must be more than 2 possible user responses. So, is your age over 18? Are you male or female? Something like that, like 2 different questions. Based on their responses, I guess. Are you over 18? Are you, over 21 or under 20? Something like that. Your code must contain at least 1 switch statement to get some practice. And then your code must make use of both string and number user inputs. So keep in mind that by default, when you get a user input, what data type is it going to be by default?
What was the question again?
The question was, when you get user input, so if I have the input box, by default, what data type is that when I type something into a form or I type something into it's a string. So keep in mind that you're going to need to convert that user input into a number if it calls for it, or an integer. And it says here in the README, just to get some more practice, keep in mind that you can use that parse int and toString methods. So maybe you want to get that input and do something to it and then convert it back to an integer or convert a number to a string at some point. Just keep that in mind, get some practice with that. Here's some inspiration. You could create some sort of Lord of the Rings style game if you're into Lord of the Rings. Is anyone watching Westworld right now? Anyone? Yeah, I got to catch up. I already read the ending because I'm a naughty boy.
So good.
It looks amazing. I've got to just catch up on that.
No spoilers.
Do what? Don't tell you?
No spoilers. I haven't saw the last 2 episodes.
Can I tell you the last 4 words of the Gilmore Girls?
Yeah, that's fine.
No, I don't want to ruin that either. So if you want to do some sort of Westworld or Lord of the Rings, you could do that. If you want to do like some sort of top shelf, if you want to do like a Harry Potter thing, go crazy, go nuts. Okay, I'll leave that to you guys. If you scroll down, here's a pseudo-coded example of, actually, if you just want to code out this example, that's fine. I mean, don't worry about it. But here's an example. So it would be something like, it would start off, what's your name? You give them your name. Nice to meet you, name. What year would you like to go to? So based on the year that user inputs, you guys can probably read through this and guess that it's like a Back to the Future example. So if you type in greater than or equal to 2015, it says, I see you're a fan of Back to the Future 2. Would you rather deal with Biff or Griff? And then enter a B or G. Based on that user input, B or G, if they put in B for Biff, interesting. Biff is angry and has a cane. Do you stand and fight or run away like a coward? Then you have S or R, stand, or run. And then those 2 choices and such. I'll let you guys read that. I think you can, kind of parse that out. Another thing to keep in mind, which is really common with user experience interfaces, is, just simple questions like, are you 18? So when you're designing your program, maybe you have in mind, oh, I want the user to put in the letter Y for yes. But you just should always assume that users are never going to do what you want them to do. What if they put a capital Y or a lowercase y? What if they type out yes, all uppercase, or capital Y-E-S? So you have to consider all of those use cases. And that's one reason that toString or parse int can be really helpful, because it helps you, no matter what the user input, you can remold it to fit your program. So whether they put in a Y, an N, a yes, a no, whatever they do, maybe they put in 1 and 0 if they're trying to do like a binary yes or no. But you can always kind of anticipate that the user is not going to do it the way you want it. So I'll let you guys read that pseudocode example. Again, feel free just to use that if you want, just for funsies. Any questions about what we're asking? Just getting some practice with conditionals and if else and switch statements.
Mark, just to clarify,
Yeah.
each student will be working on their own thing, right? Not pair programming.
Well, I'm going to put you guys back into groups. So each of you should have like your replit open, but you can work on the same code. You can talk about it. Yeah, but I would encourage you guys just to get practice typing it out yourselves. But you can work on the same, program as you talk about it. Any questions before I open up the breakout rooms again? Okay, cool. So I may give you guys a little bit more time, like maybe like 5:35-ish. Go ahead and take a 5-minute break during this time if you want. I'll close the breakout rooms. We'll come back. We'll do stand-ups quickly, and then we'll do homework, and then we'll get you guys out of here by 6, okay? So ping me if you have any questions, and I will open up your breakout room.